Today we are going to look at chapter 3.2, which is essentially deals with what are called measures of spread, which is a number, a statistic that you get from your sample. And it basically tells you how spread out the data is. So if it's a big number, it's well spread out. If it's a short, small number, it's not. So there are three measures of spread. One is called the range. Second one is called the interquartile range. And the third one is called the standard deviation. So what we're going to cover today in this section, and then we'll get started on the next one after that, is the idea that there are more than one way you can measure how spread out the numbers are. And we're going to show you how to take a data set in each of these three situations and calculate the range, what's called the interquartile range, which almost always is called IQR for short, and the standard deviation, which is called S, if it's from a sample. And it's called this funny little Greek letter here, which is sigma, if it's from a population. So if you get a question that says find S or find sigma, then you'll know what you're being asked to do. So let me start with a data set that we can use to calculate these things. One, two, three, 4, 5, 6, 7, 8, 9, 10, and 11. So here is a list of data. It could be ages of people in a family or something. And as you can see, the numbers go from 2 all the way up to 40. If you want to calculate the range, you just take the biggest number and you subtract the smallest. In this case, you're going to go 40, take away 2, and the range is 38. The range has one very big advantage over the other two methods. It's very easy to calculate. Don't you just need to know one number, who's the biggest, one number, who's the smallest, and you're good to go. Now the second guy, called the interquartile range, you get that by calculating two numbers as well, but these numbers are called Q3 and Q1. And let me show you how you do that with this data set here. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, perfect. There are 11 numbers in this data set. So if we want to pick who the middle one is, we find him first. Would you agree that the middle one is 1, 2, 3, 4, 5, 6, is that guy there? Right, the number 8, you see that guy? See, he's in the middle. That guy is called the median, isn't he? That's the name you give to the guy in the middle. It's called the median. He also has another name. It's called Q2. Now what you have to imagine is that that median has got gobbled up, destroyed by my pen. It's been used up. Now what you can see now is that there are a bunch of small numbers on one side and a bunch of bigger numbers on the other side. So the guys that we call Q1 is the middle number out of these. And would you agree that the middle number in this question is Q1? What would the middle number be on the big side? Which
19.
one of these is Q3?
19.
19. So you want to calculate the interquartile range. You get Q3, take away Q1. Q3 happens to be 19, and Q1 happens to be 3. And so the interquartile range in this question would be 16. So there's only one last guy to find, and he is ridiculously ugly to do by hand. The standard deviation. You get one question, I believe, it's question number 4 in the homework, where you have to do it by hand. Once you've done one of these by hand, you'll realize why we let calculators do it for us, or software in the case of SALT as well. So this is how you would set up your data. You go X, and that ends up being all your numbers. So 2, 3, 3, 4, 7, 8, 11, 15, 19, and 40. So that's your data. You call that X. You then have to calculate the mean, which is not an easy job for such a large set of data. So here goes. 2, add 3, add another 3, add a 4 and a 7, add an 8, 11, and 15, add a 19 and 20, and finish with a 40. And divide by 11 numbers, and we get 12. So this second guy, you calculate what this number is if you take away the mean from it. And in a lot of textbooks, this is called the deviation, or its full title is deviation from the mean. So it was 12, so that's negative 10, that's negative 9, that's also negative 9, negative 8, negative 5, negative 4, negative 1, plus 3, plus 7, plus 28. You then have to calculate what you get when you square those guys. You probably want to look at this piece of the video at the beginning when you do that homework question, number 4, I think it is, because there's a lot of steps here, as you can see already, and we're not even finished yet. What do you think is going to be the first number here when it's described as deviation squared? What do you think that is? What do you think I do here? What would the answer be? Victoria?
Would that be like the negative 10 minus 8?
Well, what would you do? You take negative 10 and square it, right? So what number would negative 10 times itself be?
Negative 100.
Is it negative or positive?
Positive, sorry.
I gotcha. And then you do the next one, you get 81, then you get another 81, then you get 64, then you get 25. Are you already fed up with this method? You know you don't want to ever do this again, right? 1, 9, 49, and the last guy is 28 squared, so God, that's going to take forever. 784.
For the deviation, what's the rule? It says x minus what?
X minus x bar. X bar is the mean. In this case, it was, what was the mean? Oh, in this case, it was 12. Right. What do we do next? Well, you add all these up. So this big list of numbers. So 1, 2, here we go, Victon's arrived. So you go 1, 2, 6, 11, 17, 27, 36, 40. 12, 13, 14, 15, 16, 17, 18, 19, 25, 33, 41, 11, 12. So you find the total. Next stage. Well, the next guy has a name. It's called the variance. And to get the variance, you take that total and you divide it by 11 numbers. Here's Chris coming now. Or you divide that total by 10 numbers. So why is there two versions? When you divide it by exactly how many data, this is the variance of the population. And when you do it with one less, so if there's 12 numbers, you do it with 11. If there were 5 numbers, you would do it with 4. We call that the sample variance. So you take these two guys and you divide them, depending which way you want to go. And let's see then what the standard deviation is. For the sample, it's called S. So what you do is you now take the square root of that number and you are finally finished. So the square root of 1210 divided by 10 is a remarkably nice answer, because most of the time these are really ugly decimals. And the top one, it's going to be the square root of 1210, but divided by 11. And that's about 10.5 roughly. When it's a population, the standard deviation uses that Greek letter called sigma. In this case, it's 10.5. Bubble around them so I can keep them. Would you agree that this last one especially was quite onerous? It's a lot of work. Aren't there lots of places you could do a tiny little mistake and then end up with the wrong answer and it doesn't work, and you get really frustrated, as you would do. So we tend to avoid doing these by hand. Now, I think the range is so easy, you could do that by hand. I mean, you do the calculation in the calculator, I mean, it's easy. The interquartile range, I guess, it depends on how many numbers there are, but it's not too bad, right? You could probably do it by hand and not get too bugged, especially if the data was in order. Now, if the data was all jumbled up, that becomes a bit of a workload as well, because won't you have to rewrite the numbers from smallest to biggest before you could even calculate these two guys? So what I want to show you now is how to do the same thing, right, with the same data set, but using your calculator. So if you have a TI-84 handy, I'll give you a few moments to go and hunt for it. If you don't, you could kind of do this with me, because sometimes it's easier to, if you hit the buttons while I'm hitting them, it'll help you remember what the buttons are. If not, I guess you'll just have to watch and look at this video later. Now, you will need a TI-84 pretty much all the time for now on. And this is just the beginning of when you really need it, but you'll need it for on and off until the end of the core. So you need to get a hold of a TI-84 somewhere. If you don't have one, you can phone up the Mesh office, MESH. You can look online for its telephone. You'll probably end up talking to Cheryl and tell her you'd like to borrow. It's a free rental. We give you for the quarter for free, a TI-84. If you go to my Canvas site, I have a software version with a funny name called Wabbit, which is hit and miss, but it works for me and it has worked for others. And you can use it like that. So are we good? You ready to start hitting buttons? Right, I'm going to do a little change here, but only a little change. Rather than use my calculator, which I could certainly do, I'm going to use the Wabbit emulator, which is just a little bit bigger. And hopefully that'll make it a little bit easier to see the buttons that I'm pressing. Right, you should be looking at the TI-84 emulator on my screen. Is that what you're saying? Good. Right, so first thing you're going to do is hit Start. Choice 1 is called Edit. Hit Enter. And then you just type in your data. So I'm looking at the list, so it goes 2, Enter, then I do the 3, then the 3. This is the hardest part, just typing in everything accurately. 11's the next number. Hope I got 8, I did. 15 and 19 is next. 20 and 40 is next. Okay, so that's the data in. So far, so good. Now, you hit the Start button a second time, and you move over to the Calc, which is there. And now you've got choice number 1, and you pick number 1, stands for 1 variable statistics, and you enter. Now, in my calculator, that's what you see. In some of the more modern ones, you get a little menu that you can go through, but it's the same thing. And on that menu, there's only one important thing, and that is where the data is stored. And in my calculator, it was stored in L1. Now, to tell it L1, you hit the blue button, number 1, and that's L1. Blue button, number 1. And when I hit Enter, we get all sorts of things. Do you see that the mean is 12? If I go a bit further, can you see that 11.28? That was a little bit out there in the 10.76. What that has told me is that seeing that table I did, I added up wrong, one of the numbers probably, or I squared one of them slightly wrong, because these are the exact values. So just as I said, isn't it very easy when you do it by hand just to screw up a little bit? But at least I couldn't have screwed up too much, because you see that the numbers are pretty close to the ones I got. Now, if you scroll a little bit further, do you see that Q3 and Q1 are there? Remember the 19 and the 3 that we used? That's there. If you look a little bit more, can't you see the biggest and the smallest? Do you see the calculator allows you either to just read off the answer, or it tells you the two numbers that you need to subtract to get the range, or the two numbers you need to subtract to get the interquartile range? Would you agree that that's a much more accurate way of doing this process of calculating range, interquartile range, or standard deviation? If I sold you on it, calculator's cool. Now, if you don't do it by calculator, then I guess you could do it by hand. I hope you decide not to, based on the one example I've shown you. And some of the other questions are much bigger than that, so you really don't want to do that. But there is another way of doing what I just said, and that is by using a piece of software called SALT, S-A-L-T. And let me show you how that works. Okay, here's the homework questions. There we go. Yeah, let's do this one. Here is a set of data. Here are the answers, right? Let's see what they look like. If you hit that big orange button called Use SALT, you will see this screen. You then hit Descriptive Statistics. And can you see it's got the mean, the standard deviation, the smallest, the Q1, the Q3. And if you scroll all the way to the end, there. Can you see everything you could possibly want to know is done for you? You don't even need to type in the data. So that's going to make calculating and finding range or standard deviation or interquartile range, whatever it is you're being asked, isn't that going to make it a lot easier to do, because basically the software does it for you. Now, I showed you how to do it by hand, so it's not magic. I want you to think of the analogy as like, you know, when you were younger, you probably had to memorize all your multiplication tables because you had to do a lot of calculations by hand. And to this day, if you gave me a 5-digit number and asked me to multiply it by a 2-digit number, I could do that by hand. But I never would when I use a calculator. Once you know how to do something by hand, you see it's not that big a deal to say, I know how to do it by hand, but it's much more accurate and quicker if I do it by calculator. So I know how to get the standard deviation if there was 100 data points, right, 100 numbers. I know how I could do it. You'd have to pay me a lot of money to force me to do it, right, because I wouldn't do it by choice. But when I just go to a calculator or a piece of software and do it for me. But at least I know what the calculation would be. I just choose not to do it. Does that seem like a fair argument for why we showed you it by hand, but why you probably won't do that many by hand? Maybe because it's onerous. So you can do it with a calculator. Now, why did I show you the calculator and not just show you salt? Because not all the questions, unfortunately, have salt. So you can't use it for everything. So, you know, you're going to have some questions where there's only 5 numbers, but you have to do it with a calculator. So that's why you've got both. Are there any questions yet? Are we comfortable about how to find those 3 guys? We good? This is your chance to ask questions if you want to. Okay, then we're going to move on and look at some properties of these 3 guys. Range, interquartile range, and IQR. So let's take another set of data. I'm going to pick a reasonably small set of data. Right, there are 6 numbers here. And I'm going to calculate by hand, because there's only 6, apart from the standard deviation. I'm going to calculate them by hand and see what we get. So the range is 12, take away 1, that's 11. The interquartile range, which is Q3, take away Q1. Now that's going to cause a little bit of a problem here. If you count this, is it there's 6 data points, 6 numbers? Where is the median in that list? Where's the middle number? Where's median? Can you see that there's a problem with where the median is? Maybe that's why I'm not getting an answer. Can you see that there's really 2 numbers in the middle? So when there's 2 numbers in the middle, for the median, don't you choose halfway? Now that makes the little wall right in the middle. It's not 4 or 8, it's 6, and 6 isn't there. Now when I do it that way, can you see that there are 3 small numbers? So this guy here will be Q1, and there's 3 big numbers, and this guy here is going to be Q3. And so the interquartile range is 10, take away 2, and that's 8. And to get the standard deviation, even for a small data set, I would still do it by hand. So here it goes. Let's get rid of all that data so I can put in some new stuff. And it's 1, and it's 2, and it's 4, and it's 8, and it's 10, and it's 12. And then I'll go stats, calc, 1 variable statistics, blue button 1. And the guy I want is SX. I'm going to call him 4.5 because to 1 decimal place he is. So if the question was, find the range, interquartile range and standard deviation of this sample, the answers would be 11, 8 and 4.5. Now, here's our first property. Suppose you add some number to all of them. Let's say I decide to add 5 to all the data. So instead of being 1, that turns into 6, and that'll be 7, and that guy at the end will be 17. Now, in the homework, you are asked to actually do that. In other words, you write down the new list and you find the 3 things. But I can tell you that I know what the answer is going to be because I already have these answers. If you take this set of numbers and you add 5, don't you basically keep them where they are as far as distance apart is and just shift them to the right? Can you see because of that, isn't the amount of spread the same before you added the 5 and after you added the 5? So that makes the range, interquartile range, and 4.5. So if you add 5 to all the data, the measures of spread don't change. So you could take a list of data and find the interquartile range. You could add 52 to all of them, and the interquartile range would still be the same number as it was before. A measure of spread doesn't measure what the values of the numbers are. What it's measuring is how spread out they are wherever they happen to be. And if you just pick a whole bunch of numbers and move all of them the same amount, you're not really changing the spread. Suppose you take all the data and you double all the data. So that'll become 2, and that'll become 16, and that'll be 20, and that'll be 24. What do you think the new values of these 3 guys are going to be now? If you double all the data, what do you think happens to the range, the interquartile range, and the standard deviation?
Would the spread still be the same?
Well, that's one possibility, and it certainly was true here. Well, let's just pick the 2 end numbers. That becomes 2 and that becomes 24. Would you agree that the range is much bigger now? 2 to 24. In fact, 2 to 24, I can do. Oh, what's happened to the range? Hasn't it doubled? Wouldn't the interquartile range double? And you'll have to trust me on this one. So does the standard deviation. I understand why you would have thought, because of this property, why it might be the same. But if you double all the data, you will double the measures of spread. So that's the two main properties that these three measurements of spread take. One is if you take a set of data and you add 20 to all the numbers, or you take away 10 to all the numbers, these things don't change. But if you double all the numbers, basically if you double them, aren't you also doubling the gaps between them? So you're spreading them out twice as much. That's kind of the argument for why it works. And there are some questions where they get you to do that. Are we good? Any questions? Thumbs up, I like. So next thing we're going to talk about, it's called the coefficient of variation. CV for short, the coefficient of variation. The coefficient of variation is the standard deviation divided by the mean. So, for example, suppose I had a data set and the mean was 100 and the standard deviation was 20. Then the coefficient of variation would be 20 divided by 100, which is 0.2. But the coefficient of variation is always written down as its percentage value. So technically, I guess I should say times 100 to make it a percentage. Now, what the coefficient of variation does, it's a number that kind of blends the average typical person with how spread out the data is. And so it kind of takes account of what kind of numbers are you working with when you spread it out. And that does have a usage. Can you imagine that you had two stocks and you were interested in how much they vary and how risky it would be and how much you could win or lose, or whatever you want to describe it? And I'll call it stock A and stock B. And so you got data on what their value was at the end of every day for a whole year. And stock A is worth $100 a share, right? That's its average price. And stock B was worth $500. And the standard deviation of this guy was 10. And the standard deviation of this guy was also 10. If you calculate the coefficient of variation for this fella here, you get 10%. If you calculate the coefficient of variation for this one, I believe, I better check it, that it's only 2%. Well, what do these numbers tell me if I'm interested in the stock exchange? This stock is worth $500, but it only moves roughly about 2%. So it's a pretty stable price, would you agree? If it's going to go up, it's probably only going to go up a couple of percent. But if you're going to lose money, isn't it probably only going to lose you a couple of percent? So wouldn't this be a stock that would be a safe bet? Now, what about this stock? Well, it's not worth as much money on average, but if you were buying $1 million, it doesn't really matter. You're buying $1 million, you're buying $1 million, right? It's the same amount. In this case here, would you agree that this stock, you could increase your stake by 10%, right? You could make 10% on a good year. But couldn't it also go down by 10%? And so this one would be a riskier bet. So if you know the coefficient of variation of a stock, can't you then use that to decide, am I a gambler? Or do I want to be pretty sure my money, I don't lose much? Okay, I might not get a lot, but I'll never lose a lot. Here, you might win a lot, but you could lose a lot. So if you want to think why someone would want to calculate it, and there's an example. In the business world, you might want to use that as a measurement of how risky a particular stock is compared to another stock. That's that done. Now we're going to do another property. After that, I'm going to look at the homework and go through it. Then we can start the next section. I think it's called Chebyshev. I think it's called Chebyshev. I might have killed the poor Russian guy's name, but it's the Chebyshev property. And it says, if you use K standard deviations away from the mean, then you will have at least one takeaway, 1 over K squared % of the data in this interval. Okay, let's figure out how that weird formula is in practice. Okay. Suppose we take the IQ of a lot of Americans, and the mean IQ is 100, and the standard deviation is 10, which is actually very accurate because that's typically what it is in most countries. Right. So far, so good. Right. Mean is 100, standard deviation is 10. Suppose I wanted to go plus or minus 2 standard deviations from the mean. Let's see what that looks like. So it's the mean plus or take 2 standard deviations. So that's going to be 100 plus or minus 2 times 10. So that's going to be 100 plus or minus 20. So we are looking at 80 to 120. So what percentage of Americans have an IQ somewhere between 80 and 120? Well, according to Chebyshev's formula, it's that guy. Well, by the way, K equals 2 in this story, right? 2 standard deviations. So according to him, %75% of your data will be in the range 80 to 120. So you could say, look, at least 75% of Americans are going to be in that range. It's quite an interesting property because what it is saying is that you only really need to know the mean and standard deviation. And from just that, you can have a fairly good guesstimate of how much data is in any given range. So let's try another one. Let's suppose I try a medical one and I'm making this up. Let's suppose that the average healthy blood potassium level is 32. I have no idea what it really is, but let's pretend it's 32. And that the standard deviation is 4. Let's do 3 standard deviations. K equals 3. Let's see what percentage of people that would work with. Well, the mean plus or minus 3 standard deviations. 32 plus or minus 3 times 4. 32 plus or minus 12. So on the low side, it's 20. On the high side, it's 44. And according to Chebyshev, 1 take away 1 over k squared, 1 take away a ninth, 8 ninths, which is about 88.9%. In other words, 89% of Americans should have a potassium level in this range. Oh, excuse me. Most of you are too young, but eventually you'll reach the stage in your life when you go to the doctor and you get blood tests and they measure magnesium and calcium and vitamin D and who knows what else, right? And maybe potassium. And when you do that, you will find that you're in the normal range, you're high, or you're low. So if someone gets a blood tested and their potassium level is 50, can you see that that is a danger sign for the doctor? It's too high. Why is your potassium too high? What diseases tend to reflect that? On the other side, suppose your potassium level was 15. Wouldn't that be considered outside the norms, and we'd consider that too low? So pretty much every body chemistry chemical you can think of, they have collected data on it, and they know what the average is, right? They know what the mean is, and they know what the standard deviation. And now you can build these guys. And so you can now measure someone and say, your calcium's too high, your potassium's too low, but your iron is bang within the normal range. And then doctors can make some kind of understanding, perhaps, of what's wrong with you. And maybe you just need vitamins. Or maybe it's a reflection on your thyroid's not working right, or something's wrong that they need to look into more. Kind of cool, Chebyshev, for what it does. Allows you to tell an interval what percentage of the data is going to be in that interval. Here's another guy, actually the last guy. You remember we talked about very extreme numbers, right? That guy, like the Bill Gates in the world, right? Way over there to the right, bigger than anybody else. We call them outliers. And couldn't you also have somebody who's really, really tall, or really, really small, or did really, really bad in the test, or has got a really low potassium level, whatever it is? Couldn't they be an outsider, but on the small side? Now, if we just give you a list of data and say, is this number an outlier or not? There's a lot of subjectivity in that, isn't there? You look at it and you think, yeah, that looks kind of too big for me. I think that's an outlier. But then you hand the same information to the person next to you and they say, well, it is big, but I don't think it's that big. It's not really an outlier. Okay? We don't like that vagary. So there is a way of testing for an outlier. It's a 2.5 standard deviation. So what you do is, imagine you had a mean of 50 and a standard deviation of 6. Then you use the 2.5 standard deviation test for outliers. So that's the mean, add 2.5 standard deviations. I guess I should have told you that. In this case, it's going to be 50 plus or minus 2.5 times 6. That's going to be 50 plus or minus 15, so 35 up to 65. And the test basically says this: if your number, your data point, is outside this interval, then it is considered to be a potential outlier. So can we pretend that I actually had some real data where this came from? And, you know, it starts at, let's say, 30, 39, and then it finishes at 62. Right, so imagine this was the data that we got, the mean was 50 and we got the standard deviation was 6. The interval is 35 to 65. Now, as you scan through these numbers, the outliers always live in the outside. So let's look at who the candidates are. Is 62 going to be an outlier according to the 2.5 test? Nope. Is 30 going to be a potential outlier? Yes. Even although it looks pretty close to 39, it's still considered an outlier, because if you do not have a lot of spread, couldn't something that's 7 away be pretty unusual? Right? If all your numbers are all stuck together. So this guy is a potential outlier. And now there is no guesswork, because you do the same calculation that I do, and you'll come to the same conclusion because of that, right? You won't say, I think it's an outlier, and someone else says, no, I don't think you're right there. That's taken away. You're going to have to use the 2.5 rule for any question that talks about outliers. But to be realistic, this is about the only textbook I know that uses the 2.5 rule. Everybody else uses the 3 rule, which says you have to be 3 standard deviations away from the mean before you're considered an outlier. But so you get your homework questions right, you're going to have to use the 2.5 rule, because that's what this textbook uses. Can we just live with that little idea, synchronicity, that the guys who did this textbook unanimously, or whatever, unilaterally, that's the word I'm looking for, and decided that it was going to be 2.5. Are we good? Any questions about everything I've done? Because what I'm going to do now is go and look at the homework, talk a little bit about what the questions are asking you to do, and then we'll move on to the next section. Last chance, any questions? Okay, that's a good sign, I hope. And let's get it set up then. So you should hopefully be looking at 3-2 homework. Is that what you're seeing? Great. I'm going to see if I can make this a bit bigger, because some of your screens are not great. I'm frightened I can make it too big, but you know, there we go. That might help, right? If you can't read it. Now you probably can. So, oops. Let's take out those answers, because those are really a distraction. Come on, go away. Don't need the answers. There we are. Right, now we can read the questions without that distraction. So the first question, which average, mean, median, or mode is associated with the calculation of the standard deviation? Which one of those 3 did I use when I did the horrible thing by hand?
Didn't you use the mean?
I did. End of the question. Didn't really say a lot about this, but I did mention it. So hopefully if you're paying attention, you caught it. What is the relationship by the thing called the variance and the standard deviation? So is the standard deviation half it, twice the variance, the square root of the variance, or the square of the variance? And I think I only did it in passing, so you might have missed it. Anybody want to put $5 on a bet? See if you get lucky.
I think it's C, but I could be wrong.
You think it is what?
C, or the third one.
The third one?
Yeah.
And you are right, it is. I did mention this. You remember that funny little sigma and the S guy? Whoops. The sample statistic is S, the population parameter is sigma. Then you get a bunch of questions that are basically, here is 5 numbers, find the range, and then calculate the standard deviation of the population and the standard deviation of the sample. Now on your calculator, because I would definitely do anything to do with standard deviation on your calculator or use salt. There's 2 guys in your calculator. One is called S little x and the other is called sigma little x. Which one of those is the population standard deviation? Well, you're going to be doing the homework question. You'll have 2 numbers. You're going to have to pick one. Do you pick the SX or the sigma x? You know, I'm getting old here and I don't have many years left.
I don't have the calculator, so I can't do it.
Well, all I'm asking is not the answer physically. All I'm asking is to use the number that says sigma x or the one that says SX for the population standard deviation.
Do you use the SX?
So the answer is, do you use SX? Well, thank you for trying. SX is sample standard deviation. Sigma x is the population one. So if you switch those around, you're good. But you did try, that was helpful. Here's the same basic questions again. The good news about this set of data is that you could use salt. But let's see if we can figure out how to answer this question just by intuition, just by looking at the 3 data sets. So data set 1 is 8 to 12. Data set 2 is 7 to 13. And data set 3 is that guy, 7 to 13. And it says, without doing any computations, order the data set according to increasing values. So one of these 3 data sets is less spread out than the others. Which one is less spread out than the other 2?
The first one.
I agree. So I'll take a little note and I'm writing it down, number 1. Now, there are only 2 guys left then. Right, so that guy's got the smallest spread, so he's out the window, right? We got him, he's number 1. Now you've got 2 and 3. Now that's a little bit harder to judge, but one of these is less spread out than the other. Which do you think is less spread out? 2 or 3?
3.
I see 2 with a finger, I'm going with that one. So that makes the answer 1, 2, 3. Boom. And then you can actually go and check it out in your calculator and pick something. This guy here I really like because doesn't it have the salt button? So if I hit that button, wouldn't I be able to get the answer to all of these without too much trouble? Let's just pretend that the answer was 7. Just top of my head. The answer to the standard deviation was 7, right? So pretend that was 7. Suppose you added 4 to all those numbers, right? What would the new guy be?
7.
Because we know that adding numbers doesn't do anything. And then you pick out a sentence that basically says what that does, like adding C to all the data, the things stay the same. And that's a whole lot of calculations. Here we do it this time. Can we pretend that that was 7? Now this time you're going to multiply all the numbers. Oh, that's a bad choice. Let's just pretend that that was 5, right? Now you're going to multiply all these numbers, right? These guys here. But you're going to multiply them by 7. What will the new standard deviation be now? Does it stay the same or do you multiply it by 7?
35.
Correct. If that was the real numbers, that's what you do. Now, that guy is just a placeholder. Don't you have to go in and find out what it is? It's 1.23 or something, right? Right. Remember the 2.5 standard deviation rule? Here is a question that basically checks that out for you. So I may have to shrink this back a little bit because I think there's the sentence missing. Here we go. One indicator of an outlier is that its observation is more than 2.5 standard deviations from the mean. Consider the data value 80. If the mean was 70 and the standard deviation is 5, is 80 a suspected outlier? Well, let's see. 70 plus or minus 2.5 times 5 is 12.5. Nope, it's not. It's something like 55 up to 85. And here's a second one, and the answer is yes, it is, or no, it's not. Here you're doing the C of V, coefficient of variation. So that's going to be, what, 2 divided by 8. And won't you turn that into a percentage, and that's your answer. So I think that's 25%, if I'm not mistaken. Now, this is not the way I phrased it, so let me tell you how this works. Remember the questions I did, 2 standard deviations and 3 standard deviations? Remember those guys? 2 standard deviations gets you 75. So if you want to know what the lower limit is, you're going to take the mean and you're going to add or subtract. Where's the add button? You're going to add or subtract 2 standard deviations. So 2 times 2 is 4. So can you imagine that the lower limit is going to be, the upper limit's going to be that, and the lower limit is going to be that. Right? Add or subtract 2 standard deviations, get you 75%. What does, how many standard deviations do you need to go from the mean to get an 88.9%, which is what this question is? 2 gets you 75. How many gets you 88.9%? Any guesses?
3.
You nailed it. It is 3. That wasn't hard. And now we're moving on to our next section, which is the end of chapter 3. Oh, good. I do not want to see solutions in them. Okay. I need to go and do some notes first. A bit early to ask you questions when you haven't even covered the work. So we're going to show you how to do what's called a box plot. You make one. It's a diagram, very special diagram. So I'm going to start off with a nice data set. 1, 5, 6, 8, 11, 13, 1, 2, 3, 4, 5, 6, 19. There's my data set. Now, to create what is called a box plot. You need to first find, so this is step one, find what's called the 5-figure summary. So the 5-figure summary is the minimum, Q1, the median, which is called Q2, Q3, and the maximum. So we're going to find the 5-figure summary. Okay, now in this data set, there are 7 numbers, right? Which one of these numbers is the median, the guy called Q2?
8.
8 it is. Do you all agree it's that guy? Now, in this case, don't you kill that guy off? Do you see you've got 3 big ones and 3 little ones? Okay, what number is Q1? Which of these 3 numbers is Q1?
Is it 5?
Yeah. And at the other side, would you agree Q3 is 13? So here is my 5-figure summary. The smallest number is 1. Q1 is 5. The median, also called Q2, is 8. Q3 is 13, and the maximum is 9. Step 2, make a scale on a number line. So the scale basically is you start with a number line, and you really, it's best if you can use this in square paper, but that's what I've got, so I'll deal with it. And in my case, the smallest number is 1 and the biggest number is 19. So you can make it look pretty. And would it seem reasonable that 0 to 20 would be a good scale to have everything that you need to show? Now, can you imagine in a different box plot, the numbers went from 55 to 90? Can you imagine in that case, your number line would only really need to start 50 to 100 maybe? You know, have all the numbers and then kind of start and finish with a nice round number. So 0, I'm going to go for 1 box represents 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So can you imagine that I had square paper here? I could do that pretty easily. And then step 3, create the box plot. Also called a box and whiskers plot. I kind of like the second name. Maybe it's just my sense of humor, but I like that. So this is how you make it happen. The smallest number is 1, so you make a little tiny mark at 1. And the biggest number is 19, so you make a little mark at 19. And if you think people are going to find it hard to tell what you're pointing at, why don't you just tell them by writing the number on the scale? Then you go to Q1, which is 5, but you don't do a little box. You do one that's, you know, if that's 1 box worth, well, you make this about 4 boxes worth. Make it noticeably thicker, bigger. And that's where you put Q1. Q2 is at 8, so that's here. And that's the same size as that, so that's at 8. Q3 is 13, element 12, 13, which is here. Then you join these guys up like that. And then this fella, I'll get slightly out of sync there. There we go. So this is what we call a box plot, right? And it contains all the information that is here. You agree it contains the minimum, the maximum, Q1, Q2, and Q3. Now you can do this same picture with 200 numbers, but you would never do it with hand. Wouldn't you just hit the salt button and it would draw the picture for you, for example, right? This box plot allows us to visualize a whole set of data. So imagine I had two classes. I'm calling them A and B. And I did a box plot of each. And we'll have that as 10, 20, 30, 40, 50. And the first class looked like this. And the second class looked like that. And if the only thing I gave you with these two box plots, there's a lot of information that you can use to compare and contrast. For instance, would you agree that class B is on average got a lot older students in it? Imagine this as ages. Can you tell just by looking at the box in the middle where the median is? Can you tell me anything about how spread out the data is? Are those two classes roughly the same variation, they spread out a lot, or not? No. Who do you think is much more spread out in age?
B.
Correct. If you look at the box there, do you know that the length of that box from there to there, isn't that Q3 take away Q1? Do you see how the length of the box is actually what Q3 is measuring, interquartile range is measuring? See that there, it's maybe 20. Can you imagine that's only about 6? Much different. Agreed? Now, without going through all the details, I am now going to show you how you can make judgment calls on what the shape of the histogram might look like based on what the box plot looks like. So can you imagine you drew a box plot and it looks like this top fella? And we'll assume that we know that the data is unimodal, right? So it's a single hill. If the data looks like this, right? Symmetric, skewed left, or skewed right? What do you think is the most likely shape for that guy?
Symmetric.
I would agree with you.
Just out of curiosity, is this like the horizontal version of candles and daggers?
Since I don't know what candles and daggers is,
it's like
it
when you
might
look
be.
at a stock chart.
Oh, I do, yes.
Yeah.
In fact, it is okay to draw them that way up. So that's what
okay.
they are.
Mm-hmm.
I just do them horizontally because that's the way my brain tends to think, but you can do them vertically. What do you think about this second one? Skewed left, skewed right, or
Skewed left.
I agree. What made you decide skewed left? Because you're right. You're correct.
Because it's more spread out on the left.
Right. Big long tail, big box, both on the left. Then it won't be a surprise that this one here is skewed right. So if they ask you to describe what you're seeing, symmetric, skewed left, skewed right. Now, if you ever, hopefully you won't, but if you ever get this combination, where it's got a big long tail, but a really skinny box, and a big fat box, but a really skinny tail. Yeah, that kind of shape. That shape, it's not called no name. That shape doesn't have a name. Can you imagine that you just randomly chuck in a whole load of numbers and there is no pattern? is just random, kind of some big, some small, some big, all over the place. That's the kind of box plot that you would end up seeing, excuse me, if there was no data involved. Any questions about that, or do you feel comfortable about that? We've got a thumbs up. Excuse me. Let's switch over to a homework question, and we'll show you how the homework, because WebAssign is online, how they get to ask you about those things. Well, hopefully you're seeing question, whatever number that is, 4. Now, we've got a whole set of data up here, and we're going to find the 5-figure summary, and then we're going to get the interquartile range, and then you're going to make a box plot. And the way they make it happen is, do you see that there's, what, 4 or 5 pictures there? Once you've drawn your box plot, don't you just go and look at your picture and see which one of them it's the same as? But since this question is here, small one is 6, maximum is 14. Let's see how many numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 1, 2, 3. Would you agree that that 11 is the middle one, and that 11 that I've highlighted is the guy they call the median, right? So I'm going to put that guy in, and then I'm going to go back and highlight that again. Now, a little bit awkward. Isn't there only 4 numbers on the small side and 4 numbers on the big side? Now, when you look at the left-hand side, isn't the middle those 2? But that's okay, because they're both 9, won't the answer be 9? Now, on this other side, this side here, isn't the middle those 2 guys? So in that case, 12.5. That makes sense? Now, interquartile range, won't you take one away from the other? By that I mean Q3 take away Q1. And one of these guys starts at a 9 and finishes about a 12.5 or thereabouts. That looks like it's finishing on the right number. It has to start on a 9. That's good. It has a 6 to 14. That is good. Pardon me. Would you agree that that one at the bottom has all the different features that we found in our 5-figure summary? And that would be what my box plot would look like when I finish drawing it. I'm getting nods. I like nods. Nods are good. Now, here is a big set of data, and all you've got is some pictures. Now, this one is not an easy question. It's not a difficult one to do, but it's going to take you time. Isn't the first problem going to be you have to put the numbers in order? Agreed? Well, the answer is no, because I'm going to show you how you can do it. Oh, by the way, you could do it that way. Nothing wrong with that. But I just remembered that there's a better way. In a few seconds, hopefully you'll see what I'm trying to do here. Right. Now, let's see, I may have to tweak this a little bit so everything appears on the screen. Ah, shooting space. Did you notice I did not swear there? Did you see how good I was at not swearing? Although I probably should have. There we go. I'm trying to have the calculator and the data that we're going to use on the screen at the same time. Right. Since I need a 5-figure summary, wouldn't it be a lot less work if I put this into the calculator and let it do it? Because if I had to do it in order, do you know I'd probably miss a number or write down the same number twice that I shouldn't have and all the other things. And oh God, there are a million places to screw up, right? So I'm going to switch it on, clear that one out. I'm going to go and do start, edit, delete all the old stuff just by hitting the delete button till they all go away. Now, it might take me a little while, so 13, 33, 12, 15, 24, 35, 46, 37, 52, 22, 18, 17, 33, oops, 33, God, 39. If I screw up here, I'm not doing this question again. I'm just going to pretend I didn't. 38, almost done. 21, 30, 41, 18, and 46. Okay, that did take a fair amount of time, but wouldn't it take even longer to write those numbers down in order? So I'm already ahead. Now, if you hit start and you move over to calc and number 1, you hit enter, and then you go blue button 1. That's how you get the data. And we get all sorts of guys, but the guys I want are at the second page. Can you see the 5-figure summary? 2, Q1 is 18, median is 33, Q3 is 38.5, and the maximum is 52. Then I should be able to just look through this set of numbers and find whichever one of those pictures ends up being, matches with that data set. And then to find the interquartile range, don't I just take 38.5 and subtract 18, which I believe is 20.5. Are we cool? So use calculator to avoid having to do anything by hand, based on the idea that when you do it by hand, it takes forever in a day. Question 7, same idea. Question 8, oh God, can you see that you really, really do want to start using your calculator? I do not want to do that by hand, right? This time, we can use salt. So if I click on salt, the data appears, or it will in a few seconds. Now, if I hit descriptive statistics and you look at this, can you see the 5-figure summary is at the end? These 5 numbers. But even better than that, if I hit charts and graphs and I hit box plot, and I hit that number, do you see it draws a box plot for me? It's kind of cool. It's pretty crude looking box plot, but isn't it enough to at least save you some time and money? I like that. Now I need to find what I did. Oh, darn it in space. Looks like when you use salt, you have to go back out and in just to get your question. We're getting close to the end of this, so that's a good thing.
If you middle click your mouse on it, then it creates a new tab.
Say that again?
If you middle click your mouse, like this button, then it
I've
creates a
done
new tab.
On my middle mouse button, it just creates this funny little arrow that allows me to
So
scroll.
if you
better.
click it on the use salt.
Oh,
Okay.
Well, you have a much nicer. My middle mouse button is actually a little roller. It's not really a button. So that's cool that you can do that. I have to do it out and in. And okay, let's look at this question where they've already created a little box plot, 3 of them. And this is Consumer Reports rated automobile insurance companies and gave annual premiums for top rated companies in several states. The figure below shows box plots for the annual premiums for urban customers, married couple with one 17-year-old son in the 3 states. So I'm assuming what they're talking about is here is your insurance, how much you pay a year for insurance in these equal situations. So it starts off with which state has the lowest premium. Now, if I look at each of them, and this is an eyesight thing, would you say California is the lowest and what, Pennsylvania is the highest? You agree with me? Yeah. I'll try and maybe make it a little bit bigger because it's kind of hard to judge. If you look at California's number, it's 1, 2, 3, isn't it? About 4 and a bit. And would you agree that one's just a tiny bit to the right? So California's got the lowest premium, and I don't think we can argue. And Pennsylvania has got the highest insurance premium. Now, I don't know why. Why is it so expensive to insure your car in Pennsylvania compared to a place like California or Texas? Does anybody, this isn't a real math question, it's just a curiosity question. What's funny about Pennsylvania that makes their insurance premium so high? Nobody's know? Is it just,
Maybe weather.
oh, harder to drive, more weather-related ice accidents, not tornadoes, maybe tornadoes, I don't know, but hailstorms damaging cars, lots more weather-related. That's a good answer. That could well be the case. I don't know where Pennsylvania is. Is that East Coast-ish? Yeah. Did they get some weird weather? Probably.
Yeah, it's right next to New York.
That might also be it. People in New York steal things a lot, don't they? So maybe you get a lot of people from New York and steal Pennsylvania cars. That was a joke, by the way. I think we need a joke. And since that one came into my head, I'm going to tell you a different one now. Scotsman, American, and a Polish guy die, and they arrive at the bottom of the stairway to heaven, and St. Peter is there with his little book with your name, and it has to be in the book or you don't get in. And he looks for the 3 of them and he can't say their names. And they're looking at him and they're saying, come on, can you not do something here? And St. Peter says, well, you know, you look young, you probably were foolish. I'll give you a chance to get into heaven. But I'm going to have to make a competition of it. So I'm going to tell you a joke on every step. And as long as you don't laugh, if you get to the top of the stairway, I'll let you into heaven. But if you just laugh once, that's it, you're going to hell. I did my best, you blew it. So the 3 of them agree and they get all serious. And they do 2 or 3 steps, and after the 3rd step, the American just can't help it. The joke was too funny and he bursts out laughing. And the other 2 look at him and boom, he disappears. St. Peter says, well, that's him gone. And the other 2 take a deep breath and get all serious again. So the Scotsman and the Polish guy, they take a few more steps and eventually they get to halfway and the Scottish guy can't help himself. The joke was just too funny. He bursts out laughing and disappears. Polish guy gets all serious and they get right to the last step and he's about to hear the final joke. And suddenly the Polish guy bursts out laughing. And St. Peter says, "Oh, come on, you almost made it. What happened?" And the Polish guy says, "Oh, I just got the first one." Did you like that joke, Victoria? Because I got the ooh look off your face there. Is that okay? Beckton, you seem to be enjoying it. I don't know if that's a good sign or a bad sign. Was that funny?
Yeah, I quite enjoyed that one. That's pretty funny.
Okay. So, back to our story about insurance premiums. Which state had the highest median premium? So if you go back here, isn't the median that line right in the middle of the box? And would you agree that Pennsylvania, if you call it winning, wins again? Would you agree? Which of those three states has the lowest median insurance premium? Which one of those three has the lowest median
Texas.
insurance? Texas. Again.